So if we're going faster than that, then we start to have this differential growth, right? Where some parts are hot and some parts are cool. A lot of people think thermal shock, well, feeding cold water to my hot boiler, that's thermal shock. Yeah, sort of. Yes, that could be an issue, and the manufacturer certainly won't recommend that. When I think thermal shock, what I'm referring to is warming up or slowing down a boiler too fast. Typical fire tube Scotch Marine boiler is going to have a recommended ramp rate of 100 degrees Fahrenheit per hour. We also see a ramp rate very similar to that or the same ramp rate in industrial water tube boilers or packaged water tube boilers. And so they want to see 100 degrees Fahrenheit per hour. So when I start with a cold boiler at 70 degrees Fahrenheit and I'm going to take that up to 338 or 100 psi, then that's going to take somewhere around 2.5 to 3 hours. So if we're going faster than that, then we start to have this differential growth, right? Where some parts are hot and some parts are cool, and the boiler starts to kind of push me, pull you, and tear itself apart when we have these thermal stresses. Again, that's very evident in a Scotch Marine fire tube. Now, the worst time for this to happen is when we're just starting to warm up a boiler. The water in the belly of that boiler is cold, it's not boiling yet. And the steam bubbles in the belly of that boiler is what stirs the water and causes the outside shell of that Scotch Marine fire tube to be heated. And then once we're making steam, also the steam is what heats the top of that shell. So if you can imagine, I have a boiler at 70 degrees and then I start firing it at high fire, for example, which would be terrible for it. Then now I've got these tubes. I'm heating these tubes up to operating temperatures or above, and the shell of the boiler is cold. And so those tubes are going to push on that tube sheet as they try to grow. And in some cases, if I imagine a tube that warms up 100 degrees hotter than the shell, that tube could create in the neighborhood of 10,000 pounds of thrust force. So those tubes are only rolled into that tube sheet. They're not welded, or maybe they're welded on one end. So that thrust force of those tubes is going to pop those tubes right out of the tube sheet, or in some cases actually crack the tube sheet. And that can be a very expensive and intensive repair to weld up the cracks in a tube sheet. So we want to be very careful of that. The opposite is true too. A lot of people think about, okay, I'm going to warm up nice and slow, but then they go to shut down the boiler and they just go ahead and put that into a fan on state. So a lot of different combustion controllers will have this fan on or cool down switch, or you hear it called different things. If I turn that fan on, I'm taking a boiler that's hot, right? 338 degrees because it was making 100 pound steam perhaps. And there could be refractory in that boiler, especially in a dry back Scotch Marine boiler. That refractory can be very hot, maybe in the neighborhood of 2,000 degrees. And I'm going to blast it with 70 degree room air or 50 degree air, or colder if it's winter. And so I'm taking this refractory that's glowing red hot, or these tubes that are hot, and I'm going to forcibly cool them down with cold air. Now we have to do some of this for post-purge and things like that, but if we continue to run that cool down switch, we can shrink those tubes right out of that tube sheet and crack the tube sheet going the other way. Or also, I think we see a lot of refractory repairs on dry back boilers because we have unhealthy warm up, but also cool down habits. That's a lot of a temperature swing to take in a really short amount of time. So warming up boilers, nice and slow, low fire, maybe even cycle that low fire on and off to stay with that 100 degrees Fahrenheit per hour curve warming up. Same thing coming down. Best practice for cooling a boiler is to just shut it off and isolate gas and isolate steam from the system and just let that boiler cool slowly over time.